Hi everyone, welcome to today STLD class, that is Binary Arithmetic Operation. So today our topic is Binary Arithmetical Operations. So in our childhood we have learned in first class, second class in our childhood, addition operation, subtraction operation, multiplication operation, division operation we have already learned. So the same addition, subtraction, multiplication, division, the same operations for the machine purpose, that is by using binary number system, how we will do these arithmetical operations, that we will see now. So in our digital side we have two types of basic operations. The first one arithmetical operation and second one logical operation. These two are very important for the digital electronics or switching theory and logic design field, right? Here the addition, that is binary addition we are going to perform here. So here we have four types of operations. The first one, binary addition. The first one, binary addition. Binary addition. So this binary addition almost all similar to the decimal addition only, but a slight modification is there. That is, here in our binary number system we are using only zeros and ones. So we are doing these addition operations in between zeros and ones only. Next, binary subtraction operation. So in the binary subtraction operation we have a special concept called borrowing concept. So how we are taking borrow, or how we are doing the subtraction in decimal, the same way here we are following the same method. So the binary subtraction, binary multiplication, binary division also. So for doing this all arithmetical operation, the common and basic principle behind these operations is decimal arithmetical operation. There is no that much of deviation from the normal arithmetical operations to binary arithmetical operation. Almost all same operations here we have, but here we have to understand the machine language. Why? Because in our decimal number system we know 2, but here the 2 is equal to, we are representing in generally 1 0. The 3 we are representing in binary number system 1 1. So in this way we have to remember the rules and we have to do the operation, right? So first one, addition. So the first one, addition. This is the normal addition. So for the normal addition, for example, if you consider two values like 59, 11. So if you want to sum, what is the value, final value? So after summing that, we will get 9 plus 1, 10. So we are placing 0 here. See here, 9 plus 1. We are placing 0 here and we are placing 1. Right? So this one is carry. This one is carry. So now 1 plus 5 plus 1. What is the value? 1 plus 5, 6. 6 plus 1, 7. So this is the final value. This is the final value. So in generally, what is this one? What is this one? Right? For example, consider this is A and this is B. What is the name for A and what is the name for B? That is, because the name for A is again and the B and the name for B is addend. Right? So the 59 is called again and 11 is called addend, and the final result is called sum. And other than this operation we have one more operation, that is called carry. So what is the carry here? 1 is the carry. Here this is the 1, this is the carry. How this carry comes? 9, we are adding this 9 plus 1. So after adding 9 plus 1 you got 10. So you have placed 0 here, you have placed 1 here. So this one is called carry. This one is called carry. Right? So remember this point. This one is called carry. Okay. So the same concept we have to apply for binary addition also. First we will see the binary rules. So binary addition. The addition of, see here, the addition of binary numbers are quite straightforward and similar to those used in the decimal arithmetic. So whatever the basic mechanism we are using, that is we are bringing from the decimal arithmetical operations only. The rules for this addition is 0 plus 0. So nothing plus nothing, nothing. 0 plus 1, 1. 1 plus 0, 1. 1 plus 1, So what is the value of 1 plus 1 in a normal decimal? The value of 1 plus 1 is equal to 2. But in binary, how we are representing the 2? In binary, we are representing the 2 is equal to 1, 0. Right? So this 0 is the sum and this 1 is the carry. This 1 is the carry. See here, 1 plus 1. The sum is 0. Here carry is equal to 1. So you have to remember this value. Why? Because the 2 number is not available in our binary number system. So the 2 we are representing as 1, 0. If you got 1, 0, 0 is the answer and 1 is the carry. So this carry will be added for the next addition purpose. For the next addition purpose. So these are the very simple rules. So you have to remember each and everything. Okay, right. Now we will see one example. So I am taking here the decimal value 6 and the decimal value 13. Now I have to add these values by using binary number system. By using binary number system, I have to add these two values. First, write down what is the value, what is the equivalent value for 6 in binary number system. That is 0, 1, 1, 0. 0, 1, 1, 0. The value for the 13 is here, we are writing 1, 1, 0, 1. Right? Actually, we can represent 6 is equal to 1, 1, 0. 13 we can represent 1, 1, 0, 1. Okay. For doing addition operation or for doing subtraction operation, for these two operations you have to remember one point. Okay. So you are taking in the addition operation again and addend. These two must be same length. These two must be same length. Actually, the value of 6 is equal to 110, but the 13 value is equal to 1101. Here 13 is 4 digits and 6 is 3 digits. So now I want to place one more 0. I want to add one more 0 for this 6. So this side if you add the 0, there is no value for that number. So remember, so I am placing one more number 0. So the length of the addend and again is must be equal. Length of the number is must be equal. Now we have to perform the addition operation. Now we have to perform the addition operation. Right. So, do the addition. What is the value here? 0 plus 1, 1. 1 plus 0, 1. 1 plus 1. Here this is very important. What is the value of 1 plus 1? 1 plus 1 is equal to here 0 and here this is a 1. 1 plus 1 is equal to 2. 2 means 1, 0. 0 is the sum and 1 is the carry, that is goes for the next series of addition. So now 0 here 1 plus 0 0 1, so 1 plus 0 1 and the 1 plus 1 that is equal to 0 is the sum and 1 is the carry. Here there is no further addition, so for that reason I am writing in this way. So finally 6 plus 13 is equal to 0110 plus 1101 is equal to the final value 10011. This is the answer. But what is this value? Actually 6 plus 13, 19. This is equal to 19 or not? We have to check. See here the value 10011. So here 2 power 0, 2 power 1, 2 power 2, 2 power 3, 2 power 4. Okay, so the value of this one is 16, 8 and 4, 2, 1. Okay, so this value you can neglect, this value you can neglect. Next, the value is 16 plus 2 plus 1, that is equal to 19. So this is the addition operation. So you have to remember. For example, just this example is completed. Now consider, for example, here also 1 is available. Here also 1 is available. Then 1 plus 1 plus 1. Here we have 3 ones. 1 plus 1, 2, 2 plus 1, 3. We will get answer 3. What is the 3 equivalent number? 1, 1. That is, here the carry is 1 and sum is also 1. These two also 1, 1. You have to remember this point. Very, very important. Okay. So, 1 plus 1 is equal to 1, 0. 1 plus 1 plus 1 is equal to 1, 1. Okay, so here we have 2 ones, so answer is 2. 3 ones, answer is 3. 3 in equivalent number, binary is equal to 1, 1. So in this way you have to do the addition operations. So So here this is the sum operation for the given numbers. So here we are placing carry. So this is called carry. You have to remember this one, and this is the final solution. 0 1 1 0 plus 1 1 0 1, that is equal to 1 0 0 1 1. For your confirmation purpose, the equivalent value is 6, this equivalent value is 13, and the equivalent value is 19. 16 plus 13 is equal to 19. So finally, this is the 19 equivalent binary number. So remember their process. Okay. At the last, I will give some more problems you have to practice. Next, coming to the subtraction. So here I am giving some of the problems for your practice purpose. So take down, first take the snapshot, otherwise note down in the notebook, then start doing these problems and submit these answers for these problems by tomorrow morning. Next, binary subtraction. So first we will see the subtraction. What are the terms? Just before that we discussed that one is added and second one is again. For example, take 59 minus 11. Previously we have taken 59 plus 11. Now I am taking 59 minus 11. So what is 59 called and what is 11 called? Okay, here the 59 is called minute and 11 is called subtrahend and 48 is called difference. Okay, then here one more concept is also there. In addition we have carry, in subtraction we have borrow. In subtraction here we have borrow. See here 9 minus 1, the value is equal to 8. 5 minus 1, the value is equal to 4. So 59 minus 11, 48. It is very simple concept. And here we have one more concept, that is borrow. How this borrow will works here? How the borrow will works here, that we will see now. Right. So binary subtraction. So when you are doing subtraction, you have minute, that is upper one, subtrahend, that is downer one. Right? So here remember, minute is upper one and subtrahend is downer one. So minute minus subtrahend is equal to difference. If you have any borrow, you have to write down borrow. So here, take the second value and apply 2's complement. For doing subtraction purpose, here we have a special method called complement operation. This is very important. Generally, the machine knows the summing operation, but the machine doesn't know about the subtraction operation due to the borrow concept. So the borrowing concept is not known by the system, but the machine can perform sum operations and carry operations also. So for that reason, in the place of subtraction, for example, a minus b, the b is here we have with minus b. So this minus b we are finding first. How to find the minus b? Okay, first you have to take the b. For minus b, you have to take the 2's complement value, right? So this is b, original value. How to get minus b? For getting this minus b, you have to take 2's complement of b. 2's complement of b. So this is the procedure you have to remember. You have to take the 2's complement of b. Then that is equal to minus b. So remember this point. Add 1 to the result. See here first, before that, apply 2's complement. Change 1 for 0 and 0 for 1. Okay, change for 0 and 0 for 1. That is for 1's complement. After completion of 1's complement, you have to add the 1 for the result. After doing 1's complement, you have to add 1. Then that is called 2's complement method. Next, add the complementary value to the first value. During the addition, we disregard the last carry. So for identifying this carry, first you have to take 1's complement, then add 1. Then you will get 2's complement of b. That is equal to minus b you will get. Actually what you have to do, you have to do the operation a minus b. So you got minus b. That is nothing but as a plus of minus b. I have minus b ready made. Okay. So what I have to do here, a plus of minus b. I got minus b. You have to sum to this value. Why? Because plus into minus, minus. That is very important. Okay, so here actually a minus b operation is there. In the place of a minus b, we are doing a plus of minus b operation. A plus of minus b operation. Remember this one. And how to get minus b? Here a is given value. Minus b. How to find the minus b? For getting the minus b, you have to take 2's complement of b. This is very, very important parameter. Remember everyone. Next. So coming to here, for doing normal subtraction, right, without 2's complement, if you want to do by using your brain, you have to remember this value. 0 minus 0 is equal to 0. 0 minus 1 is equal to, here this is very important. I will say as 0 minus 0, 0. 1 minus 0, 1. 1 minus 1, 0. 0 minus 1. Here, 0. 0 minus 1. Okay, 0 minus 1. Generally, what we will do, here there is no carry. Here we don't have any, sorry, here we don't have enough value to subtract this value. So you have to take some borrow. If you take the borrow, here the value is equal to 10. Okay, so from this 10 means the value of 10 in decimal is equal to 2. 2 minus 1. 2 minus 1, 1. So the answer is 1. The answer is 1. And here I am writing, I have some borrow that is equal to, the borrow is equal to 1. So difference is equal to 1 in between these two. Difference is equal to 1 and power is equal to 1. So this is the value. Right? 0 minus 1, that is equal to 1. This some difference is 1 and the borrow is 1. This is very, very important. Right? So this is the subtraction process. Next. So we will do. So we will see here one example how to subtract a value. For example, a, b. Here a value is equal to 1101 and b value is equal to 1011. Some values I have taken. Actually, what is the equivalent for the value for this one? Apply 8, 4 to 1. 8, 4, 1. 8 plus 4 plus 1, that is equal to 13. 8 plus 2 plus 1, that is equal to 11. Okay, 13 minus 11 is equal to 2. This is the value you will have to get at the end. That is equal to the value of this one is equal to 0, 0, 1, 0. Why I represented with 4 bits? Why? Because that A value were represented with 4 digits, B value we represented with 4 digits. I said that A value, B value and sum value, it must be equal length. Maybe the sum value or difference value might maybe 1 bit maybe high. That is length, if the length is equal to n, the sum value or difference value n plus 1. Maybe it 1 n plus 1. You have to remember this one. Here A minus B operation we have to perform. Right? This is I am writing A plus of minus B. Okay. So first I have to find minus B. What is the value of minus B? Minus B is equal to 2's complement of 2's complement of B. 2's complement of B. So here what is B? What is B? B is equal to 1011. Okay, for B, 1's complement of B, that is equal to 0, 1, 0, 0. In the place of 1, you put 0, 0 place, you have to put 1. 1 place, you have to put 0, 1 place, you have to put 0. This is 1's complement B. So, 1's complement of B plus 1 is equal to 2's complement. So, here you have to add 1, right? So, this is the 1, right? Add this one. Okay, so by adding this 2, 0 plus 1, 1. 0 plus 0, 0, 1 plus 0, 1, 0 plus 0, 0. So this is the 2's complement value, that is equal to, here the minus B is equal to 0, 1, 0, 1. Is it clear? So the 2's complement value for B. So this is the given value 1, 0, 1, 1. For this 1, 0, 1, 1, for this 1, 0, 1, 1, the equivalent B value is equal to 0, 1, 0, 1. Now, according to the previous step, what they at the last what they said, add the complemented value, add the 2's complemented value to the first value, to the A. We have to do A plus of minus B. We got minus B. Now you have to perform A plus of minus B. So here we have A. So A value is equal to 1101 and B value is equal to, here B value, what is the B value? That is a minus B. That is minus B, you have to write down. You have to write down minus B and you have to add these two values. Minus B value is equal to 0, 1, 0, 1. Now add these two values. 1, 1, 0 and result. Here carry is equal to 1 and sum is equal to 0. 1 plus 0 plus 0. This is 1. 1 plus 1, 0 and 1 carry. 1 plus 1, 0 and here we got 1 carry. Here in this subtraction process, you neglect this value, right? You neglect this value. You have to neglect this carry. There is no necessity of remembering the carry. So there is no necessity of taking carry. So the final answer is equal to 0, 0, 1, 0. Right? 0, 0, 1, 0. The equivalent value for in decimal is equal to 2. This is the in decimal. So 13 minus 11 is equal to 2. That is equal to 00, 0, 1, 0. So we got the value 0, 0, 1, 0. So remember this concept. Remember this concept. A minus B. And this concept mainly applicable for A greater than B. That is, A value is bigger with compared to B value. Okay. If A is equal to less than B, that is, A is smallest value and B is biggest value, then what you have to do? So remember this one. Now all of you note down this one and I will start explaining the second condition. If the value is A less than B, right? So A value is very smaller compared to B. For that, what we have to do? Okay. Right. Here I am taking 1, 0, 1, 1 and B I am taking 1, 1, 0, 1. So this value 8 plus 2 plus 1, that is equal to 11 and 1, 1, 0, 1, the value of this one is equal to 13. So 11 minus 13 is equal to minus 2. Okay. So what is the equivalent value for minus 2? Minus 2 is nothing but as 2's complement of 2. Actually 2 value is equal to what? 0, 0, 1, 0. Minus 2 value is what? So first you have to find the 1's complement for this one. Right? 1's complement for this one. One's complement of 2 is equal to 1, 1, 0, 1. So 2's complement of 2, that is equal to, add 1 for here, 1, 1, 0, here 1, 1, here we will got, this is, remember, carry. This is carry and here 1 and here 1. So this is the answer. So what is answer? 1 plus 1, 0, 1, right. So this is the minus 2. 0, 0, 1, 0, 1, 0, 1. After adding this one, 0, right. So this is minus 2. So finally, minus 2 is equal to 1, 0. Okay. So see here, previously I said that A minus B is equal to A plus of minus B. Okay. So when we are doing the operation, we will get some difference value. That difference value should be 1, 0. That value should be 1, 0. Why? Because here, what is the answer? It's 2 or minus 2. 11 minus 13 is equal to, the answer is minus 2, not 2. But 2 value is equal to 0, 0, 1, 0. But what is minus 2? Minus 2 is equal to 1, 0. That we will check now. Okay. So A is equal to 1, 0, 1. Now, I have to do A plus of minus B. Now, B is equal to 1, 1, 0, 1. Okay. For this 1's complement. 1's complement 0, 0, 1, 0. And add 1 here, 0, 0, 1, 1 and minus B, that is 2's complemented form, is equal to 0, 0, 1, 1. So this is the 2's complemented value. Now A value is equal to A is equal to 1 0 1 1 minus B is equal to here 0 0 1 1 0 0 1. Is it clear? 1 1 0 1 0 0 1 0. Right, everything is right. So here A plus of minus B we have to perform here. Okay, 1 plus 1 is equal to 2. 2 value is equal to 1 0. So write down 0 here and write down carry here. So this is carry. Go, remember, this is carry. This is carry, right? 1 plus 1 is equal to 2. 0 is the right sum and 1 is the carry. Here we have carry 1 and here we have 2 ones. 1 plus 1 plus 1, that is equal to 3. 3 is equal to 3 value we are representing in binary with 1 1. Right? So we have 1 1. So here 1 is the sum and 1 is the carry. Okay, next 1 plus 0 plus 0. Here we have only 1. So 1 plus 0 plus 0, that is equal to, answer is 1. Next 1 plus 0, 1. So this is the value. A minus B is equal to 1110. So is this minus 2 or 2? See here. So minus 2 is equal to 1110. A minus B is equal to, we got 1110. Okay, right? So this is minus 2 representation. Remember, 2's complement of 2. This is the 2's complement of 2. Why? Because 11 minus 13 we have to get minus 2. For minus 2 we are representing like this. Why minus 2 we are representing like this? Minus 2 is nothing but as 2's complement of 2. So 2 value 0 0 1 0. 1's complement of 2. Reverse this value. In the place of 0 1 you put 1 and in the place of 1 you put 0. So 1101. Next add 1 value here 1110. So this is the result. This is the minus 2. Here A minus B, after performing by A minus B, I got 1110. Right? This is for A less than B condition. This is for A less than B condition. Remember, it is very remember, this is very important. Is it clear? So you have to practice a lot of problems at your home. Next, we will see multiplication. Binary multiplication. Oh, sorry, before going to the binary multiplication, just we will see normal multiplication. So I have taken one value 202 and I am multiplying this value into 12. What is the final value? And here this is called multiplying. Oh, sorry, this is called multiplying. That I will write here. So this is a multiplying and this is multiplier, and these are all called partial products. So this is the first stage partial products and this is the second stage partial products and these are the final products. Remember this one. And what we are doing in generally multiplication, 2 2s are 4, 2 0 0, 2 2s are 4. Okay, so first I am multiplying with first bit. With this bit I am multiplying these 3 values. Next with this bit I am multiplying these 3 values. With 1 I am multiplying, that is 202. 1 into anything, that value. So 202. So 4 2 4 2. So this is the final value, that is 2424. This is the answer. In generally multiplication we are doing in this way. The same way you have to perform binary multiplication also. In this multiplication, remember, this is multiplying and this is multiplier. These are the partial products and this is the final product. Okay, so can we do one example on this multiplication? Coming to rules is very simple. 0 into 0, 0, 0 into 1, 0, 1 into 0, 0, 1 into 1, 1. So whenever both values are 1, then only the answer is 1. In the remaining condition, all are zeros. Okay, so binary multiplication also similar to the multiplying decimal values. Multiply each digit or bit using the standard method. Add the results using the binary addition rules. Rules for binaries are for binary multiplication. So this is not subtraction. This is multiplication. For binary multiplication, these are the rules. Okay. Now we will do one example here. So here the value is equal to A multiplied and multiplier, that is 1 1. So what is the solution? Here you have to do the multiplication operation. Okay, 1 into 1 1, 1 into 1 1, 1 into 0 0, 1 into 1 1. So this is the final answer. Next you have to multiply with 1. If 1 is there, you have to write down in this way. And the positions of the values are very, very important. So 1, you have to write an asterisk. 1 plus 1, 0, and carry is equal to 1. 1 plus 0 plus 1, 2 ones are there. So 0 and here one more carry. Okay, 1 plus 1, 0 and carry here 1. 1 plus 1, 0 and carry is here. We have to, this is the final answer. Okay, so the value of this one is equal to 3 and here the value of this one is equal to 11. 11 3s are 33. 11 3s are 33. Is this value is 33 or not? We will check. 2 power 0, 2 power 1, 2 power 2, 2 power 3, 2 power 4, 2 power 5, 1. So neglect this value, neglect this value, neglect this value, neglect this value. So 2 power 5 is equal to 32. 32 plus 1 is equal to. Is it clear? So this is the very simple operation. In the sum, if you got at the end excess bits, remember these values you have to put. Okay, in the multiplication, if you got an extra value, you have to put. That is the final value. In the subtraction, if you have any carry, in sometimes you have to neglect the carry, in sometimes you have to add the carry. That is based on the condition. So this is the rule. This is the rule. Remember this. This is the example of multiplication process. Okay, right. Next, we will see division operation. Right, binary division operation. Right. So you are habituated with this, otherwise I will. Okay, right. So here, check. 24 1s are 24. There is a chance of subtraction. 24 2s are 48. There is also a possibility of subtraction. 24 3s are 72. That is not possible. So for that reason, 2 times. So made here 48. And the remainder is 2. So this is called remainder and this is called divisor. This is called dividend and this is called quotient. Here divisor, this is called divisor and this is called dividend and this is called remainder and this is called quotient. Okay, remember these are other values. Okay, here we did the subtraction operation for 50 and 48. Okay, so this is very important, remember. Now we will see the binary division process. Binary division process. For example, I have here 1 1. Next 1 0 0 1 0 1 0. Some value is here. Okay, so first we will check. So first each bit we will check. So there is a chance with multiplying this value 1 the minimum value, this is 3. So 3 into 1, that is equal to 3. The minimum value is 3, but here we have only one value. So there is there is 0 times, there is no chance. So put here 0 times. 1 minus 0, 0 and say take the second digit. Okay, now try to divide with this 11 value. So both are zeros, there is no possibility. Okay, write down the value. Wait. Let us see the binary division operation. Let us see the binary division operation. I am taking an example. So 1001010. This is called dividend, and this is called divisor. After performing, you will get final remainder. And here you will get some quotient, right? So in the division operation, these four are very important. Remember, right? So for doing division first, take first bit, there is a chance to divide, there is no chance to divide, put 0. So 1 minus 0, 1, and next 0. So this 1, 1 is possible to divide with this 1, 0, there is no possibility, right? So there again 0 times. So the result is 1, 0. Here we have to perform the minus operation, 1, 0. Next take third bit, 1, 0, 0. Can we perform the division operation with 1, 1? Yes, is there possibility? Put 1 and here put 1, 1. Okay, actually this value is equal to 4, 1, 0, 0 is equal to 4, 1, 1 is equal to 3. Like that you can perform. Otherwise, take this 1 to here. Alright, so see here 1, 0, 0, 1, 1. Take this 1 to this position. This one converts as 1, 0. Okay, so here you have to again bring this value to here. In this you have to bring one value. Actually here we have 1, 0. 1, 0 equivalent value 2. In this 2 you have to bring one value to here. So if you bring any one value to here, so here we can perform 2 minus 1 operation and the 1 will be here available. 1, 0 minus 1. 1, 0 means 2. 2 minus 1, the value is equal to 1. Here how much value we have? Here we have 1, 0 or 1. We are already taken one value to here. So for that reason, here have only 1. Here we have only 1. 1 minus 1, 0. And here this is 0. So finally 4 minus 3, that is equal to 1. 4 minus 3, that is equal to 1. Right. So 1, 0, 0 minus 1, 1 is equal to, answer is 1. Here this is 0, this is 0. Okay, there is no next of writing this 2. So 1 we got from this result. And you have to take down one more value, that is 1, 1. Right, 1, 1. So 1 times. So 1, 1. Here you got 0. So the final value is 0. And up to here we have down, taken here. Now the value here you have to put 0. In 0, 0, there is no chance to do the value 0 times. So here 0, 0. So from this value here. So the 0 is the remainder and here this is also completed. Now you have to down this value 1. There is a possibility to do the division 1, 1 this with this value. There is no possibility. Again you have to put 0. We got here 0. So 0. Here this is 1. Okay, and you have to put 0. So this 1, 0 is possible to divide with this 1, 1. There is no chance. So finally this is the remainder. Finally, this is the remainder. So this is very, very important. Binary division operation. In this binary division operation, we have lot of subtractions, multiplication and subtractions operations. Here we have performed. Multiplication is a series of addition. So you have to remember here the addition. The machine can ready to do that operation, but subtraction machine can't. Why? Because machine know the complement operation, machine doesn't know about the borrow concept. So for that reason, for the subtraction purpose, we are taking the subtrahend value with the 2's complemented value and we are doing the sum operation. That means indirectly in the subtraction we are using addition operation with the complement operation. Next, multiplication. We know already from childhood, so many members saying multiplication is a series of additions. Okay, next, division. Division is a combination of series of additions and subtractions. Majorly the value of the division is majorly depends upon the subtraction, but internally we have a lot of multiplication also. For that multiplication we are again using addition operations. So the sum operation is the very, very and most important base point for this the division operation or subtraction operation. So you have to remember this concept and you have to practice. So finally, I will give the homework with nearly 8 to 9 problems for each and every operation. 2 problems I am giving. So collect the information from the Morris Meno textbook. Okay, at the end of first unit we have lot of addition, subtraction, multiplication and division operations. Let us practice those problems.